Hi everybody, this is section 6.4 and we're going to talk about rhombuses, rectangles, and squares in this section. Okay, a rhombus, a rectangle, and a square are all parallelograms. They're special parallelograms. A rhombus is a parallelogram that has 4 congruent sides. A rectangle is a parallelogram with 4 right angles. And then a square is a parallelogram that has 4 congruent sides and 4 right angles. All right, so here we have a rhombus, and they want us to find the value of x. And we just learned on the last slide that we know all rhombi have congruent sides. So that means that side AD is going to be congruent to side DC. So to find x, I can say, I'm going to work over here, we'll do 5x minus 7 is equal to 3x plus 5. I'll solve my equation. I'm going to subtract 3x from both sides. We'll end up with 2x minus 7 equals 5. I will add 7 to both sides. So I get 2x equals 12. Divide by 2, and x is going to be 6. And then to find the measure of each side, we're just going to substitute in our 6. So I'll do 5 times 6 minus 7. So 30 minus 7 should give me 23 for that side. This DC should be the same, but let's check. 3 times 6 is 18. 18 plus 5 will give me 23. So both sides equal 23. All right, so this slide is good because it kind of shows a relationship between the special quadrilaterals or parallelograms that we've been talking about. We know a parallelogram has 2 pairs of parallel lines. Opposite sides are parallel. And then we talked about a rhombus that has 4 congruent sides, and a rectangle has 4 right angles. Well, a square is a combination of both of those things. It has 4 sides that are equal in length and 4 right angles. So a square can be considered a rectangle, and it also can be considered a rhombus. So a special type of rhombus, a special type of rectangle. So just as a review for parallelograms, remember a quadrilateral is a parallelogram if and only if opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and its diagonals bisect each other. Now, it's important to note that all of these properties also go with a rhombus, a square, and a rectangle because they are special parallelograms. So all of these properties apply to a rhombus, a square, and a rectangle. We will look at some other information about the diagonals that will differentiate a rhombus from a square and from a rectangle as well. All right, so here they want us to identify which parallelogram is a rhombus, a rectangle, and a square. They want you to be as precise as possible, so they want you to give the best name. It's like, think of this, you know, there are lots of dogs out there, so I could meet a dog and call it a dog. But if I want to be more specific, I could say that's a golden retriever. Or, you know, my neighbor has a poodle, my other neighbor has a golden retriever. So be as specific as possible. Give the most specific name that you can. So if we look at A, I know that all 4 sides are not congruent. Looks like opposite sides, I have 1 pair of opposite sides that are congruent, and then the other pair is a different length, but they are also congruent, because it is a parallelogram, so we do know that. And then the corners are right angles. So this, the best name for this would be our rectangle. All right, for B, looks like all 4 sides are the same, and then we're going to have 4 right angles. So this is going to be our square. And for C, I have a 130-degree angle. And then I also know, so opposite angles would be the same, but all four sides are the same. So they're not 90 degrees, but all four sides are the same. So this is going to be a rhombus. All right, so here, I mentioned earlier we were going to talk about the diagonals of a rhombus, a square, and a rectangle. And here, if you have a rhombus, then we know a rhombus is a parallelogram, so the diagonals are going to bisect each other, but they are also going to be perpendicular. So in a rhombus, the diagonals not only bisect each other because it is a parallelogram, but they also are perpendicular. So they'll form 90-degree angles. The diagonals in a rhombus also bisect a pair of opposite angles. So if you take a look here, diagonal AC bisected, so diagonal AC right here, bisected angles 1 and 2 and 6 and 5. And remember, if it bisects an angle, it makes it two equal angle measures. All right, so now we're going to look at the diagonals of a rectangle. And we know that the diagonals of a rectangle are going to bisect each other because, again, they are part of a parallelogram, or they are a parallelogram. And here, the diagonals of a rectangle are going to be congruent to each other. They don't form perpendicular lines, but they are congruent to each other. So the diagonals of a rectangle will bisect each other, and they are also equal in length. All right, so here we have a rectangle, and it's rectangle RSBF, and we know that diagonal SF is equal to 2x plus 15, and diagonal RB is equal to 5x minus 12, and they want to know the length of a diagonal. Well, we just talked about our diagonals of a rectangle. We do know that they are congruent to each other, so that means I know that 2x plus 15 is going to be equal to 5x minus 12. So I'll subtract 2x, and that means 15 is equal to 3x minus 12. Let's add 12 to both sides. So 3x is equal to 27. If we divide by 3, that means that x is going to equal 9. So x is 9. So if I look at these choices, I'm like, oh, my answer is B. But the question's asking, what is the length of a diagonal? So if x is 9, let's plug it into one of our two problems. I'll pick this one. So I know I'll do 2 times 9 plus 15. So 2 times 9 is 18. And then we do 18 plus 15. So that is going to give me, 33? So the length of each diagonal is going to be 33 units. All right, so here they want us to find the measure of each angle numbered angle in this rhombus. And just to recall, remember that the diagonals in a rhombus are perpendicular to each other. They bisect each other, and they also bisect opposite angles. So let's start with angle 1 here. Because I know that the diagonals in a rhombus are perpendicular, angle 1 is going to be 90 degrees. Now, because a rhombus is a parallelogram, I do know that opposite angles are congruent, which means that this angle is congruent to this one. And I also know that this diagonal right here divided that angle, bisected that angle into two equal parts. So that means that if this angle is 58 degrees, then both angle 3 and angle 2 or the measure of angle 2 and the measure of angle 3 are going to be 58 degrees. Now, I got to figure out 4. I don't have any other angle information here, but I do have a triangle here. I know that 1 is 90 and 3 is 58. So if I just do 90 plus 58, we get 148. I know all 3 angles in a triangle equal 180, so I'll do 180 minus 148. So we get the measure of angle 4 is equal to 32 degrees. All right, and the last problem we're going to do for this section is they want us to find the value of x. And they gave us a rhombus, and they told us it's a rhombus, and they gave us one diagonal in that rhombus. And just recall that the diagonals in a rhombus bisect opposite angles. So that means that this angle here, angle ABD, is going to be congruent to angle DBC. So to find the value of x, I'm going to set both expressions equal to each other. So I'm going to do 6x minus 2 is equal to 4x plus 8. Solve the equation, so I'll subtract 4x. It's going to give me 2x minus 2 is equal to 8. I will add 2 to both sides. So I get 2x equals 10. Divide by 2. And x is going to equal 5. And that is it for section 6-4.